Welcome back, guys. We are still under stoichiometry, and right now we are going to use stoichiometry to calculate the volume of gaseous products and reactants. So our next heading here is calculating volume of gaseous reactants and products. So under this heading, we are essentially going to see how much volume can be produced by a given reaction. So let's go to an example straight. An example says that the equation below shows the reaction between copper and corn sulfuric acid. The equation below shows the reaction between copper and sulfuric acid. So here is the equation: copper plus sulfuric acid aqueous. The product is copper sulfate, which is aqueous, plus sulfur dioxide plus water, which is the liquid. We realize that sulfur is there 2 times, so we multiply this by 2, making oxygen 8. And when you look the other side, we only have 7. So we multiply a 2 here, and the equation is in ballast. Now the question is, calculate the volume of sulfur dioxide that can be produced when 1 gram of copper, when 1.9 grams of copper react with sulfuric acid. So question says, calculate the volume of sulfur dioxide that can be produced when 1.9 grams of copper react with sulfuric acid. So that is our question. They want us to calculate the amount or the volume of sulfur dioxide that can be produced if we reacted the 1.9 grams. Back to equation interpretation. This is the copper, a solid, reacting with sulfuric acid, which is a liquid, to give us copper sulfate, which is a solution, sulfur dioxide gas, water, which is a liquid. Now again, we are using our knowledge of interpretation of equations. This is 1 mole of copper that is producing 1 mole of sulfur dioxide. So now, but here we are talking in terms of mass and volume. We know that 1 mole of copper weighs, in fact, this should have been given in the bracket as 63.5. Now, we know that 1 mole of copper is producing 1 mole of sulfur dioxide, and 1 mole of sulfur dioxide occupies 22.4 liters at STP. So this question, however much they have not talked of STP, we shall take it in a way that we are calculating these volumes at STP. So let's look at the solution. Let's look at solution. Now we are saying the RFM, or the relative molecular mass of copper, produces 1 mole of sulfur dioxide that occupies 22.4 liters. Therefore, here we have the freedom of saying that 63.5 grams of copper produce 22.4 liters of sulfur dioxide. Okay? Now, what will happen if we react 1.19 grams of copper? So from first principles, this will be 1.9 times 2.4 divided by 63.5 liters of sulfur dioxide. Let me get a calculator and we compute. This is 1.9 times 22.4 divided by 63.5. This gives us 0.67 liters of sulfur dioxide. So we have calculated the volume that can be occupied by, a volume that can be produced if we react 1.9 grams of copper with conch sulfuric acid. Now, another example. The example says, this is example 2 under calculating volume. The example says, given the following equation, so our equation of reaction is a reaction between lead 2 nitrate plus HCl, and it gives us lead 2 chloride aqueous plus nitric acid 6 plus nitric acid. So we need to balance 2 here, and I think 2 there, and the whole thing is now balanced. Now the question is, calculate the volume of HCl at STP. Calculate the volume of calculate the volume of hydrogen chloride at STP that would react with 20 grams that would react with 20 grams of lead 2 nitrate. So there goes our question. That is our question. They want us to calculate the volume of hydrogen chloride at STP that would react with the 20 grams of lead. And in the brackets here, we have lead is equal to 208, nitrogen is 14, oxygen is 16, chlorine is 35.5, and hydrogen is equal to 1. Now that is our question. Now, they're asking us to calculate the volume of hydrogen chloride that would react with the lead 2 nitrate to give us the products that we are seeing on the other side. Now, let's look at the solution. One, before we answer, we should look at the interpretation. Which interpretation is working for us? This is hydrogen chloride, is a gas. So this is lead 2 nitrate reacting with hydrogen chloride gas. Now they are saying calculate the volume of hydrogen chloride that would react with 20 grams. Meaning we are using grams, we are interpreting this question in terms of mass in relation to volume. Now, when we relate this question in terms of mass or moles, we know, or we are saying that 1 mole of lead 2 nitrate reacts with 2 moles of hydrogen chloride. It is the same as saying that the relative formula mass of this lead 2 nitrate reacts with 2 times 2, 22.4 liters of hydrogen chloride. So now let's begin by getting the relative formula mass of lead 2 nitrate. Now we know that lead is 208 plus bracket. This is nitrogen, which is 14 plus 16 times 3 bracket times 2. Let's get a calculator here. 208 plus bracket 14 plus 16 times 3 close bracket times 2 gives me 332 grams. Now this tells me we can call that molar mass. That is the molar mass of lead 2 nitrate. So we are saying that 332 grams of lead 2 nitrate react with these are 2 moles of hydrogen chloride, yet we said 1 mole occupies 22. So it is reacting with 22.4 liters of hydrogen chloride gas. Now they asked, calculate the volume of hydrogen. Yes. Now they say we have 20 grams of lead 2 nitrate reacting with the HCl. Now if 332 grams give us this volume, now what of 20? Therefore 20 grams of lead 2 nitrate react with the 20 times 2 times 22.4 divided by 332 liters of HCl. So let's compute. That is 20 times 2 times 22.4 divided by that. Here we get, let me reconfirm my answer, 20 times 2 times 22.4 divided by 332 is correct. This is 2.69 grams, liters of hydrogen chloride gas. So that is how we could go about such a problem. So therefore, guys, let's pick from here in the next video. Thank you.